Hey everyone, I'm Marta, and I'm a student at McGill University. I'm in the program called Quantitative Biology, which means I get to study both biology and physics at the same time. I chose this program because I like learning all about the world around me, whether it's how plants grow or why certain magnets are attracted to each other, for example. But today, I'm going to be talking to you about a topic in physics called force. A force is a push or a pull that happens on an object that usually causes the object to move. For example, I have my ball of yarn over here. If I pull on the ball of yarn, I'm causing a force on the yarn that makes it move. If I push my ball of yarn, I'm also applying a force on my ball of yarn that makes it move. Sometimes you can apply a force to an object, but the object actually doesn't move. For example, I have this heavy stack of textbooks here. I'm going to try to give them a push. Okay, it's too heavy. See, this time, I still applied a force to the textbooks by pushing it, but it didn't move. There are forces all around us. One of the most famous ones is called the force of gravity. Gravity is a force that pulls all of us down to the ground of the earth, so we don't go flying out into outer space. You might not be able to see or feel gravity, but it's still there. Another cool force is called torque. Have you ever been on a seesaw? If you have, then you've definitely experienced torque. Let's take a look at a seesaw. Something interesting about a seesaw is that it has a point called a pivot. A pivot is a spot on an object that does not move while the rest of the object does. As you can see, this pivot is staying in place while the rest of the seesaw is moving. There's a special word for the movement of the object around a pivot point, and it is called rotation. So as you can see, the seesaw is rotating around the pivot point. It can rotate to the left and it can rotate to the right. As I mentioned before, there's a special force called torque. And the reason torque is so special is because it has to work on an object that has a pivot point. So going back to the seesaw, I can explain that torque is a push or a pull that causes an object to rotate around the pivot point. I'm going to show you how to do a fun activity at home that you can use to experiment with torque yourself. The first thing you need for this experiment is a long, thin object. And I chose this ruler because it's easy to see where the center of the ruler is. The next thing you need to do is take a string and tie it around the center of the ruler. And then you just need to take a piece of tape and tape your ruler to a shelf or anywhere it can hang from. There we go. Oopsies. The next thing you do is take a piece of paper and fold it into eighths like this. Now you need to draw a creature on your piece of paper. You can draw any creature you want, but the most important thing is that it has some hooks on the top and the bottom, like this. Once you're done drawing, take the scissors and cut out your shape. Alright, so because you folded your paper into eighths, once you're done cutting them out, you're going to have 8 creatures in the end. And you can even color or decorate them like I did. Now that we have our creatures, we can start learning about how torque affects the ruler. let's go over a few things that we already learned. Remember, the pivot is the point in the object that doesn't move while the rest of the object rotates around it. In this case, the pivot is where the string is tied around the ruler. As we see, if we pull on this side, the ruler rotates. If we pull on this side, the ruler rotates. If we pull where the pivot point is, the ruler does not rotate. Now let's see what happens when we add a creature to the ruler. As you can see, the ruler has rotated, which means that the creature has applied a torque on the ruler, causing it to rotate around the pivot point. Now that you have all 8 of your creatures, you can also experiment with them and see if you can change the torque. For example, what happens if I move the creature closer to the pivot point? Oh, it looks like the ruler barely rotated at all, and that means when the creature is closer to the pivot point, it does not cause a big torque on the ruler at all. Now go ahead, experiment, see what kind of torques you can create. Some ideas I have for you are adding more creatures to the chain and seeing if that can make the torque bigger. You can add creatures to the other side of the ruler and see if you can balance the torque. You can even try moving your pivot point around if you want to. You can really do anything with your creatures and your ruler. So just remember, have fun and stay safe. Thank you for watching.